Hello everyone, in this video we are going to talk about Michael reaction. Michael reaction is used for alkylating the beta carbon of the carbonyl compound. So it is used for alkylating the beta carbon of the carbonyl compound. So now what is used for Michael reaction? Michael reaction uses alpha beta unsaturated aldehyde or ketone or an ester or an amide. Okay, so when you react this with an enolate ion in the presence of a base, you will get a 1,5-dicarbonyl compound. Okay, so normally the enolate ion should be generated from a carbonyl compound which has two electron withdrawing groups. So some of the examples include beta diketone or beta diester or beta ketoester or beta keto nitrile. So these are some of the sources that you can use for generating the enolate ion. Remember, the enolate ion is a very weak base, so normally it will do the conjugate addition, which is the addition at the beta position, beta carbon of the alpha beta unsaturated carbonyl compound. Okay, now let's get started with the actual reaction. Okay, so here is the alpha beta unsaturated carbonyl compound. Here it is specifically alpha beta unsaturated aldehyde. And for the enolate ion, I have chosen beta diester. And here is the structure of beta diester. When you react it with a base and the corresponding solvent, the base is going to go grab this hydrogen. Remember, the hydrogen is right here. They are very acidic, and therefore one of the hydrogens will be lost to form the enolate ion. Okay, and this is the structure for the enolate ion. Once the enolate ion is formed, this is going to act as a nucleophile attacking the beta carbon. Okay, and the electrons from the double bond is going to go delocalize onto the next carbon, and the electrons from the double bond is going to go on to the oxygen. Okay, now let's draw the product, or not the product, the next intermediate. So it's going to be okay, so this is the next step. Okay, and remember, this part is actually derived from the beta keto or beta diester, and this part is actually derived from alpha beta unsaturated carbonyl compound. And now the next step is to protonate the, okay, I forgot a double bond right there. Okay, so the next step is to protonate the double bond, or the nucleophilic attack of this double bond on this hydrogen. As these electrons and oxygen comes in, the double bond will become will act as a nucleophile and abstracts the hydrogen from the water molecule and gives the final product. Okay, now why this is a 1,5 dicarbonyl compound? So when you look into the structure, you can, if you start the numbering, let's say that this is your aldehyde, which is your functional group. This is the aldehyde, that's the functional group. And if you start numbering it with 1, 2, 3, 4, 5, the fifth carbonyl is actually, the second carbonyl group is actually in the fifth position with respect to the first carbonyl group, and that's why it is called as 1,5 dicarbonyl compound. Okay, and I want you guys to do this exercise and see whether you are able to attempt it.